Okay, I'm recording now. So we're going to start the breadboard demo. I request that you pay attention, but if you feel like you know breadboarding or don't want to pay attention, then I'm not going to tell you that you have to watch me go through this if you know what you're doing. But given that you have a lab next week on these topics, you should probably get a little review and refresher. So first question everybody has, what is a breadboard? Maybe you know, maybe you don't, so I'm just going to assume you don't. So you kind of have, I love the green too that you can hardly see on here. That's actually, I'm going to pause it real quick. Yeah, that's a good. I don't have one, so. Okay, I'm back, and this time with a color that you can see more easily. So, wait a minute. It's okay. We'll work it out. I can use both sides of this. This is a cool dry erase marker. Yeah, thank you. So, the way this breadboard works, yeah, that's what I did. You'll have these dots on either side. There's a line right here that's going to be red. There's a line right here that's going to be blue. Okay, and all of these in these columns, if you're looking at it this way, are electrically connected. So I'm going to show the camera and I'm going to show you. So if you look at the breadboard, all of these across these columns are electrically connected. That means a voltage at this pin up here is going to be the same as this pin down here. And if you connect two different voltages, you're going to have problems. So I'll go around the room now for you guys real quick. You have your own as well, so hopefully you know what I mean. If you don't know what I mean, feel free to stop me and we'll slow down and go over it. So now that brings us to the next part. So then there's a red line, there's a blue line, and then there's going to be some other dots, like 4 or 5. And those are all connected in rows. So same idea. The signal, it can be accessed from any one of those points. So what that looks like on here is this all the way to there across that row. This row is all electrically connected, and it's divided across this middle. So this kind of like gap in the middle separates this side from this side. So it's this separates this side from this side electrically. Okay, so fantastic. So one of the first things you most commonly do is connect up power. So this is going to go to a 3.3 volt source, and this is going to go to ground. The reason why you do that is now you can access your 3.3 volts or ground from anywhere on the circuit, on the breadboard that you're working with. So I'm going to go ahead and actually wire that up and set that up over here. You're welcome to come up closer if you want to get a view of it. I'm going to steal this PLD that is laying around. Not steal it, borrow it. Should say that since I'm on recording. It's on record. Hopefully, oh, one of the pins on this one is broken. There we go. Okay. So get myself set up. So when you have your PLD, if you want to see this, you're welcome to come up here closer for the demo. And we have our 3.3 pin right here. So I see 3.3 right next to it. So I connect up to this red side right here using a wire. And on the other side, I'm going to take ground. That wire is broken. I'm going to take ground right here. So this pin goes into the hole right next to it because those are electrically connected. Connect it to the blue rail is what we typically call it. And then I'm going to connect across the two rails. So what I mean by that is I'm going to take this red rail over here, put a wire into any one of them, and also connect it to this side. Likewise, I'm going to take wire, put it in the blue rail, also connect it to this side. So now ground and power are connected on both sides of the board. So I'll go ahead and show what that looks like. So red to red, blue to blue. Don't mess that up. 3.3 volt, or my bad, 3.3 volts down here to the red rail and ground to the blue rail right there. Okay. Now I'll take that around the room and check it out right here if you'd like. So it is just powering the breadboard, if you will. You don't need to power the breadboard, but it gives you your power rail so we can use it. So the next fundamental thing that we're going to talk about is how do we input any information to our circuit? And we do that using the dip switches and LEDs. So the dip switches, nice. Thank you. The dip switches look like this. And it says on up here. Okay. So a bit hard to see, but there's going to be a bunch of switches that look like this that can be slid back and forth here. And then there's going to be a pin on this side and a pin on this side. The way that you can model these is as a switch like this. So it's either like this, like a broken wire, or just a wire. When it's in the on position, it is acting as just a wire. When it's in the off position, it's acting like a broken wire. Okay? That's what a switch does. This type of switch. This is specifically a single pull, single throw switch that we're talking about. I think the recording is mirrored too. So this is working out great so far. Hopefully it's clear enough. We'll see. We have office hours if it doesn't work out. So let's talk about how we configure the switch circuits. And this is actually kind of critical because there will be an exam question on this, and it will be the easiest exam question you've ever answered in your life if you pay attention. I'm going to show you how you wire up your circuits in this class every single time. I drew that a little high, so we're going to draw it down here lower. Every single time, they're going to look like this, okay? And you're going to be asked to draw a switch with a pull-up resistor, and this is what you draw. Got it? So why? Well, so if you want to know why do we need the pull-up resistor, the answer is for circuit reasons. For the purposes of this class, I'm not going to go into too much depth about it, but what it means is when the circuit is open like this, the voltage is high, okay? The voltage is high when the circuit is open. So if I ask you, okay, you have this switch circuit and you wired it up correctly, what is the voltage output on this side? If there's like a pull-up resistor right here, whatever, the answer is high. On has nothing to do with the voltage. On has to do with it being open or closed. Okay. When it's open, because we're using a pull-up resistor, the voltage is high. And we'll see that in a minute when I do the actual demo. So that means when it's closed, the circuit looks like this. We're taking the voltage right here. Once again, I drew it so the camera can't see. I'm just going to draw it right here. So if you close the switch, this voltage is now low.
Even if you measure at the same point?
Yes.
Why?
Okay, yeah. And so this is a thing I'm not supposed to get into, but I will. So right now, there is no way for the voltage to fall across the resistor when the circuit's open. So if you have 3.3 volts up here, this has to be at 3.3 volts as well. There's nothing. When you create a path to ground, like that, now you're going to have all your voltage drop. You're going to have 3.3 volts drop across this resistor. And so this is 0 volts. This is low. It's connected electrically to ground.
Wait, so that's the battery.
So this is how we make the switch circuits give us the toggle between low and high. And we'll see that. I'm going to build one for you right here and in real life. So that's what's going on with the switch circuits. You always build the pull-up resistor. So first thing I'm going to do is just put the dip switch on there. You're welcome. Like I said, everybody's welcome to come up here, move up closer if they want to check out what's going on. Yeah, absolutely. You're welcome to follow along as well. So you have a package in your kit that looks like this. Looks like this. It has all the chips on it, the ICs, integrated circuits, and your dip switch and LEDs and stuff. So the first thing we're going to do when we put it on there is we're just going to put the switch circuit on there like that. Just put it on the board so it straddles the middle part right there. And now we're actually going to use these SIP resistors. And so now I'm going to briefly talk about SIP resistors. For SIP resistors, looks like this. It looks like this. And there's a bunch of lines coming out. It kind of looks like a little animal. Almost trying to do it this way. But what happens here is this dot tells you kind of like the I don't know, I don't want to call it common. I guess it is common. It's common to all the resistors. The SIP resistor electrically is modeled like this. It is the side with the dot next to it has no resistance. So why do we do that? Because each of these is going to connect to a switch. So the switch could be closed, could be open, it doesn't matter. But each of these connects to a switch. Got it? This connects to VCC. So the pin with the dot on it connects to VCC, and then all the other pins are going to line up with your switch. Okay, so I'm going to build that on the breadboard now. So I'm going to take one of the SIP resistors and find the dot. The dot is over here on mine. I don't know if the camera can see it very well. And the way I place it, I'll show you in a minute, don't worry. The way I place it is just like this. Let me show it on here first. So that the side with the dot right here does not line up with the switch, but all the other pins do. So what this does is each one's going through a resistor connecting back to that dot. You want to try it out?
Yeah.
Okay. Cool. So now let's make those connections. I'm going to go ahead and connect the SIP resistor to VCC with a wire. Takes a minute sometimes so I don't break the wire. There we go. So it looks like this. Connect the side with the dot to VCC. I'm going to connect the other side to ground. And I only need 2 switch circuits for this one because I'm going to be making a simple AND gate circuit. Okay, so I connect the other side switch to ground. So now I can toggle these back and forth and they'll go between a low and high voltage. I did not line the connection up correctly, so now I have to redo that. That could be a problem later. Okay, now both of the switches are connected to ground. So this is how you build your switch circuits for this class. I'll carry it around the room so you can take a look. There might be slight variation, different wires, but this is what it looks like. This is just a demo, me helping you. You'll be building it next time. You'll be building something like this, a bit more complex than I'm doing right now. Okay, so now that's great. So what do we do with our inputs? Well, obviously, all you've talked about right now is combinational logic. So we're going to feed it through some combinational logic. And in particular, I'm going to make a very simple circuit like this. All active high signals so that nobody gets confused here today. Okay. So all active high signals, it's mirrored on the recording, but I think it's clear enough. I have A active high and B active high going into an AND gate, and be Y active high. if I make a voltage table for this, I'm not even going to make a truth table. I'm going to make a voltage table because we know how this should behave in terms of voltage levels. An AND gate, when is an AND gate output high? Both of them have to be high to get a high output. All the other cases, it's low. So backwards again, but like I said, you have the only time the output's high is when both inputs are high. So pop quiz here. For the switches, does that mean they're for both inputs to be high? Are they going to be on or off? They're going to be off, right? Like we talked about, we want it open to get the high voltage from our input. So very good. So now, how do we get this AND gate though? Very philosophical question. But the answer is it's a 7408 chip. Okay. And we need the pinout document. Luckily, all the pinouts are on the course website. So I'm actually going to pull that up via screen sharing right now. Oh, wrong class. The software docs, text version of pinout. And so this right here. So I'm going to leave this up for a second, then switch it back to the board. So this is the pinout that I'm sharing on Zoom. I'm about to draw it on the board, so don't worry. Okay. So now looking at the AND gate, it comes in a package like this, has a little knot up here. And it's labeled pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. Now on almost all, I probably drew this too high to see. No, I didn't. I can move my computer back. We're problem solvers. Okay. So the way that we, on almost all chips we'll use this semester, if you use an IC, 7 is going to be ground and 14 is going to be VCC. That's true for almost all of them. 7 ground, bottom left ground, upper right when you're looking at it this way. So let me get one of the chips out. So let's get the 7408. So I'll look for SN74HC08. Found it? Okay, this is it right here. Really hard to see on my terrible camera quality, but if I'm looking at it so that I see the notch on the top, like I said, this is connects to ground, this connects to VCC. So now the question is, which input should we use? And we see we have like 1A, 1B, 1Y, 2A, 2B, 2Y. And we got 3Y, 3A, 3B, 4Y, 4A, 4B. So why is that? Well, the answer is there's 4 true input AND gates on this chip, or BNOR gates if you like mixed logic. So we can choose to use any one of these. We could use this AND gate, we could use this AND gate, we could use this one, or we could use this one. Today, I'm feeling like using 3. I'm going to use this AND gate right here on there. So let's get that set up. So all I need to do is connect 14 to VCC, 7 to ground, and wire my switch circuit inputs to 3A and 3B. Okay, and so I'll show you how to do that now. We're going to set that up on the breadboard. Okay, so I'm going to place the chip. Place the chip, like we said. This pin goes right there. This other pin goes to voltage. Now I wire up the input, so I'm going to get some slightly longer wires for that. And so I can get the input from right here. Or right here. Doesn't matter because all of them are electrically at the same voltage. So what that looks like, it's like this now. Okay. So I'll go ahead and walk around and show you. This is with the AND gate wired up right now. Like that. There. And over here, we got the AND gate added in and the switches connected to it over there. Okay, very nice. So now we're almost there, but we need to figure out how do we view our output? How do we tell if our circuit's working? And the answer is light. In particular, LEDs. So you're going to use dip LEDs for dual inline package. They look exactly like the switches. They're a rectangle. They have lights on them that are like this, going across there. And one side has a notch. This side is called the anode. The other side is called the cathode. The only time the LED turns on is when the anode is high and the cathode is low, a lower voltage compared to the anode. So if I put 3.3 volts on the cathode and 0 volts on it, well, I'm going to say 1.8 volts. And the reason why is that's probably the rated voltage for it. If you put 3.3 volts right here and 0 volts right here, you're probably going to destroy your LED. Which brings me to my next important point, which is why you need the dip resistor. But we'll get to that in a moment. So if I put 1.8 volts right here, 0 volts right here, that's probably okay. I don't know. Something like that. You have to use a resistor in this class though. But what I'm trying to tell you is this won't even turn on in the first place. In order to get it to turn on, you need a low voltage on this side and a higher voltage on this side. So it needs to go through a resistor to VCC. Okay, this would turn the light on. Now here's a pop quiz for some of you as well. Does the resistor go on this side or this side, and why? This is right now, it doesn't matter. And actually the correct answer is it doesn't matter. It doesn't matter if I build a circuit like this or if I built it with the resistor down here instead. What matters is I have the resistor. And I can prove that to you and show you. The reason why is kind of a circuits topic, so I'm not going to get too far in depth. If you want me to walk you through it, we can talk about it after lab section. I have office hours right after this, but doesn't matter. You need one resistor on either the anode or the cathode side. Doesn't matter. I'm verify that's true. So how do we wire up the dip resistors? The dip resistors are probably the simplest thing in the kit, and that's because it's just a bunch of resistors going across. So this pin and this pin it just goes through resistors. That's it. There's a pin on either side of the dip package. Each one is a resistor that we put in series. So what we mean is, imagine we have our AND gate. Imagine we have our AND gate. It has inputs. Its output is going to go to one pin, and the other pin is going to go to the anode side of the LED, and the other side goes to ground. Okay, output from the circuit through the resistor to the anode, other side to ground. The alternative to this is you could do output to anode, cathode to resistor to ground. Don't draw circuit diagrams like this. This is terrible. But it gets my point across, hopefully. Output has to go through the resistor somewhere in the LED. And for an active high circuit, the output goes to the anode or cathode, everybody. Anode. Good try, though. Good try. Good luck on lab one. Goes to the anode side, okay? The side with the knot. The only time it lights up is when the side with the knot is high relative to the side without a knot. Here's a quick little fun fact that Dr. Schwartz told me not to cover today, but I'm going to cover anyways to help you. If you haven't, so if you drew an LED schematically, this is, I don't know why you would draw a circle there. You would have something like this. Well, you only need one resistor. It helps if you know what you're doing, like this, and then you might draw some little lightning bolts right here. This is if you replace this VCC with like A active high or something, this is an active high LED circuit. An active low LED circuit looks like this. You connect this side to VCC, you have your LED, you got a resistor, and then you have A active low. This is an active low LED circuit. You'll probably need this in your lab 1, and you'll definitely be asked to draw these on at least exam 1. So pretty simple schematic. If you don't understand it, ask me and I'll explain it better. Well, let's do that. Let's wire up our dip resistor, and I gotta watch the time because I have to still give the little short quiz today. I need somebody's dip resistor. I don't. Do you have a dip resistor? That's a dip resistor. It's the ones that you have on there. I need to take it off. Okay. I'll bring it back. Oh. Okay. I got the dip resistor. Boom. Gonna place it on the board. We're gonna put it right here, and hopefully that leaves me enough room. We're gonna route the signal, the output signal. So the output signal goes right here. It's gonna go through this resistor. And like I said, it goes through the resistor to the side of the LED with a notch right here. So the notch is in this corner. It's really hard to see, but it's there. The other side has to go to ground. And with that, this circuit should be complete, and it should implement an AND gate. So I should be able to make them both high and have the LED turn on. So I'm gonna walk around with that. This is what it looks like over here. I'll let people play around with this once I verify it's working, and I don't need to plug it. So now let me get stuff out of my bag so I can plug it in. And now we're going to test it by plugging in the PLD. And if I built everything right, we could have an AND gate. If not, I get to teach some debugging skills. Okay, this is a good sign. The LED is on. So if you want to come over here, see this, how we toggle the LED on and off, you're welcome to come up here. The LED is on right now, and luckily that's what I would expect because both switches are in the off position or the high voltage is coming out of them. And as we know, an AND gate does high and high output high. So if I toggle one of these, the LED goes off. If I toggle both of them, it stays off. And if I test the last input combination, it still stays off. The only time it's high and on is when both of those are high voltages, or AKA in the off position for this course. So that is a short breadboarding tutorial. I'll let you take this, hold that, play around with it. Hopefully it was helpful. We'll see if this video makes the cut. Thank you very much.